Hello everyone, I'm Zhang Yi from Wenzhou-Kean University, College of Science and Technology, and with my classmates Yan and Zhou Lichen. In this video, we are going to give our 22 for CPS 3250 final presentation, and our topic is about Banker's algorithm. So first, let me introduce you the Banker's algorithm. Banker's algorithm is a resource allocation and deadlock avoidance algorithm, and it was first used in banking system, aiming at allocating different resources. So when several processes are requesting different types of resources, this algorithm can check whether there exists a safe sequence that can satisfy all requests. If not, it states that the system will be in unsafe status. The original version of Banker's algorithm is designed in a nested for loop to check all the requests, and so the processes, which cause quadratic time complexity. So when number of processes is huge, the system may take much time to solve the problem. So here is the drawbacks of Banker's algorithm. The first one is we have mentioned above, is the time complexity. And the second is that once an unsafe status is detected, the algorithm cannot solve the problem. So next, let's welcome Yanan to introduce the next part.
Now I'm going to introduce the optimizing time complexity Banker algorithm. Now we will translate the Banker algorithm into Java, and we find that we have to use double loop to achieve the goal. However, we change the recheck process now, start from the first process and run the method and until we find that there is a process is failed to allocate. Now we would move the process to the end of the array, and the step replace the recheck process in original Banker algorithm. We don't need to iterate all the array again. Next page is about pseudocode. 看一翻一下。The pseudocode, now we can see there is only one loop in our algorithm, and which the most change is we use the switch to change the pi to the end of the array. And next, so I'm going to introduce the experiment method. Every time all the processes are initialized and pre-allocated randomly, at the same time, initial system available resources are also randomly initialized. For each sub-experiment, we can edit the total number of processes and the total number of resources along with their random range. Now, we got the result about the true algorithm. As we can see in the orange line is always lower than the blue line, which means our algorithm has optimized a lot, and the true experiment will determine the resources or thread and make the result. Next is our method about how to solve deadlock problems.
Okay, I will introduce the improvement for Banker's algorithm about solving unsafe sequence. Once an unsafe status is detected, we can solve this by releasing allocated resource of some processes. By doing so, processes that are unable to get executed may have the chance to be executed. Next one. And we also compare the three methods with same numbers of resources and find the average. We can see that although the method which can solve unsafe sequence is a little bit slower than the method which cannot solve the unsafe sequence, both of them are obviously quicker than the original algorithm. So after that,
Wait a minute.
Next one. After that, we also want to find a better way to solve this part. And then, once the unsafe statute detected, we release the first element of unsafe sequence previously. And this part, we try to release the element with largest state and prevent system process be released. Next one. We also compare the two methods at the same time with fixed number of results. The cost increased merely 4%. And at the same time, the strategy is obviously better because now system process will not be sacrificed. And that's all about our improvement about banker algorithm for solving unsafe sequence. Then Johnny will make a conclusion to you.
In our optimization